Have you ever looked up at the night sky and felt small? Space is unimaginably big. When you gaze at the stars, you are looking at light that has traveled for millions, sometimes billions of years to reach your eyes. Each twinkling dot is a story of the past, a glimpse into the vastness of the universe. Our planet Earth, where we live, is like a tiny speck of dust in this vast cosmic ocean. Think about a basketball. Now imagine a tiny grain of sand next to it. That's how big Earth is compared to our sun. But let's take a step back and think about our place in the universe. The sun, which seems so enormous to us, is just one of the countless stars in our galaxy. Imagine holding a grain of sand on your fingertip. That grain of sand represents Earth, and the basketball represents the sun. The scale is mind-boggling, isn't it? And the sun is just one star in our galaxy, the Milky Way. The Milky Way is a vast collection of stars, planets, and other celestial bodies, all bound together by gravity. Our sun is just one of the billions of stars that make up this galaxy. The Milky Way has billions of stars, even more than the grains of sand on a beach. Imagine walking on a beach and picking up a handful of sand. Each grain represents a star in our galaxy. Now think about how many grains of sand are on that entire beach. The Milky Way is just one of the billions of galaxies in the observable universe. Each galaxy contains billions of stars, and many of those stars have their own planets. The sheer number of celestial bodies is beyond comprehension. Now imagine billions of beaches. Each beach represents a galaxy, and each grain of sand on those beaches represents a star. The universe is so vast that it stretches our imagination to its limits. That's how many galaxies are out there in the observable universe. Each galaxy is a cosmic city, bustling with stars, planets, and possibly even life. The universe is a grand tapestry of wonders, and we are just a tiny part of it. So the next time you look up at the night sky, remember that you are part of something incredibly vast and beautiful. Space travel is not like driving a car. You can't just stop for gas or ask for directions. We need to carry all our fuel with us. Imagine packing for a trip around the world and having to take all your food and water from the start. That's what it's like to launch a spaceship. The distances in space are mind-boggling. Light travels incredibly fast, but it still takes time to cross these vast distances. We measure distances in space using light years. A light year is the distance light travels in a year. That's really, really far. Think about how much gas your car needs to go across town. A quick stop at the gas station, and you're good to go. But what if your destination wasn't just across town, but across the galaxy? The challenges of fueling a car are nothing compared to the complexities of fueling a spaceship for interstellar travel. Now imagine traveling to another star. The distances are mind-boggling, and the amount of fuel required is astronomical. We're talking about journeys that could take decades, if not centuries. The fuel needed for such a trip is far beyond what we use in our daily commutes. We need a lot of fuel to power our spaceships. Traditional rocket fuel is heavy and takes up a lot of space, which is a significant limitation. Engineers and scientists are constantly looking for more efficient ways to store and use fuel in space. Scientists are working on new technologies to make space travel more efficient. They are exploring everything from nuclear propulsion to antimatter engines. These advanced technologies could potentially reduce the amount of fuel needed and make long-distance space travel more feasible. One idea is to use solar sails. These sails would capture the energy from the sun, just like wind sails catch the wind. Solar sails could provide a continuous source of propulsion without the need for traditional fuel. These sails would capture the energy from the sun, just like wind sails catch the wind. The concept is simple but revolutionary. By harnessing the power of sunlight, we could travel vast distances without carrying massive amounts of fuel. Another idea is to develop new types of engines that use less fuel. Innovations like ion thrusters and plasma engines are already being tested. These engines are more efficient and could make space travel more sustainable. This would allow us to travel farther and explore more of space. Imagine the possibilities: new planets, new stars, and perhaps even new forms of life. The future of space exploration depends on our ability to overcome the fuel challenge. But for now, fuel remains one of the biggest challenges for space travel. The quest for more efficient propulsion systems is ongoing, and each breakthrough brings us one step closer to the stars. Until then, every trip to space is a reminder of the incredible distances and the immense energy required to traverse them. Our bodies are adapted to life on Earth with its gravity and atmosphere. But in space, things are different. Astronauts face unique challenges. Without gravity, our bones and muscles weaken. Imagine floating in water all day. You wouldn't use your muscles as much. Astronauts exercise for hours every day to stay strong. They also take special medications to help their bones. Space is also filled with harmful radiation. On Earth, our atmosphere protects us. Spaceships need special shielding to protect astronauts from radiation. Section 5. Time twists and turns in space. Time is a funny thing in space. It's not just a concept we use to keep track of our daily lives, it's a fundamental part of the universe's fabric. When we think about time on Earth, we often imagine it as a constant, ticking away second by second, minute by minute. But in the vast expanse of space, time behaves in ways that can boggle the mind. You know how people say, "Time flies when you're having fun"? This saying captures how our perception of time can change based on our experiences. When we're engaged in enjoyable activities, hours can feel like minutes. Conversely, when we're bored or waiting for something, minutes can feel like hours. This subjective experience of time is just the tip of the iceberg when it comes to the mysteries of time. Well, time can actually pass differently in space. This isn't just a theoretical idea, it's something that has been observed and measured. Astronauts aboard the International Space Station, for example, experience time slightly differently than we do on Earth. This phenomenon is due to the effects of both speed and gravity on the passage of time. It's all thanks to Einstein's theory of relativity. Albert Einstein revolutionized our understanding of time and space with his groundbreaking theories. According to his theory of general relativity, massive objects like planets and stars can warp the fabric of space-time, causing time to slow down in their vicinity. This effect is known as gravitational time dilation. It's a bit complicated, but basically time is relative to speed. The faster you travel, the more pronounced the effect becomes. This is known as time dilation, and it means that time can pass at different rates for different observers, depending on their relative speeds and positions in a gravitational field. The faster you travel, the slower time passes for you compared to someone who is standing still. Imagine two identical clocks. One clock remains stationary on Earth, while the other is placed on a spaceship traveling at a significant fraction of the speed of light. As the spaceship accelerates, the clock on board will tick more slowly compared to the clock on Earth. One stays on Earth, and the other travels in a spaceship at super high speed. This isn't just a thought experiment, it's been confirmed by experiments with atomic clocks on high-speed aircraft and satellites. The faster the speed, the greater the difference in the passage of time. When the spaceship returns to Earth, the clock on the spaceship will show that less time has passed. This means that the astronaut on the spaceship would have aged less than people who stayed on Earth. This mind-bending concept has profound implications for space travel and our understanding of the universe. It's like something out of a science fiction movie, but it's real. The idea that time can be stretched and compressed depending on speed and gravity challenges our everyday experiences and opens up a world of possibilities for future exploration. As we continue to venture into space, our understanding of time and its mysteries will only deepen, revealing more about the universe and our place within it. Section 6. Can we reach the end of space? So, if space is so big, can we ever reach the end of it? That's a great question. Here's the thing, space might not have an end. Imagine a balloon with dots on it. Now blow up the balloon. What happens to the dots? They all move farther apart, right? That's kind of what's happening to the universe. It's expanding like the balloon. So, even if we travel in a straight line, we might never reach an end because space itself is always growing. Section 7. Beyond the horizon, what's out there? If we can't reach the end of space, what's beyond what we can see? Well, that's where things get really interesting. Some scientists believe in the multiverse theory. It suggests that our universe is just one of many universes out there. It's like bubbles in a giant cosmic bubble bath, but these are just theories. We don't have all the answers yet, and that's what makes space exploration so exciting. Section 8. Keep looking up. Space is full of mysteries waiting to be solved. The more we explore, the more we realize how much we don't know. So, keep looking up at the stars and asking questions. Be curious. You never know what amazing discoveries await us in the vast expanse of space. Who knows? Maybe one day, you'll be the one to make the next big breakthrough in our understanding of the cosmos.